So we're back with another interesting topic coming from Tenderly. It's Branislav Milojković. He has been working in tech since 2009, working in some early stage cutting edge startups, then spent most of his time actually in academia teaching programming classes to students. And today he's going to share, he will try to demystify the blockchain and how do developers kind of perceive this, and what are some of the main challenges and difficulties that developers face when they actually want to get enrolled and start working with blockchain. That's one of the biggest challenges that Tenderly is facing. So he will try to demystify some of these challenges and how to approach it so we can get one step closer to understanding blockchain even better. So Branislav, please, the stage is yours. Final check. How many people don't speak Serbian? Please raise your hands. Okay, so we do English. Thank you.
Sure. Hi, everyone. My name is Bane. I come from a company called Tenderly. Tenderly is a local blockchain development company. And in the spirit of what we do and how we do things, since we make we make tools for developers working on the blockchain. And then we decided, when we were thinking about how we should approach Swag for this conference, we decided to give you something that you can also work on. So you should find in your seats a little present that we gave you, but it's not complete Swag. It's something that you're going to have to work on your own as a little gift from us as well. So let me share a bit about what we're going to talk about in this talk. Blockchain is already a pretty loaded term, right? So you may already have some preconceived notions about what the blockchain is, what you can do on the blockchain, what it is for, things like that. And I want to approach blockchain from a developer's perspective. So I want to focus on what blockchain as a development platform offers. I want to talk about what are some of the issues that developers working on the blockchain face, and then from that perspective we can maybe see what are some of the real potentials for this technology. We can see where some of the hype that comes from blockchain is really how it came about, why people are excited about blockchain in that specific way. And hopefully, by the end of this talk, you're going to get some sort of sense about what are some of the issues that you're going to face while working as a developer on the blockchain. And if this is something that might interest you, how we approach solving these issues for different developers and things like that. What we are not going to do in this talk is I'm not going to try to sell any NFTs to you. I'm not going to try and shill some sort of token that we developed, things like that. So just so you know, this isn't something that you need to be afraid of. So by the end of the talk, we won't be selling anything to you. What we really want to do is work on professionalizing the blockchain space. We want to think about what are the real challenges that developers face when they work in this space. And then to start, we're going to have a bit of a 101. So as was mentioned in the introduction, I come from academia, so this is maybe a bit of a professor coming out. But I want everyone just to be on the same page about what it is that blockchain offers, how it works, and to understand that we need to go from bottom up. And this is maybe something that you've already heard. If you have, I'm sorry. We're going to have just a brief overview of what it is that blockchain just as a fundamental infrastructure offers. And then from there, we can go and see why everyone is so excited about blockchain and why some issues that are very prominent and prevalent, especially if you are on Twitter, why they appear and how they come about. So, blockchain, the first thing you're going to hear about blockchain when you hear about blockchain is that it is a decentralized system. And this is nothing new. So decentralized system exists from Web 1 days, right? We had emails sent through email clients, and we were running our own email servers back in the 90s, right? So none of this is really new. What blockchain as a decentralized system offers that is different is this replication of data, right? So you have a bunch of nodes, so it's like specific software running on individual computers, and anyone can run a node. So this is like one big thing about blockchain. Anyone who wants to, he can run a node. And then on this node, he's going to have access to the same data that everyone else has. So this is different and strange, because usually in decentralized systems or in distributed systems, you would spread out the data on different computers, right? You would want to use them efficiently and have some data over here, some data over here. That's how a torrent or a peer-to-peer system might work. Here on the blockchain, we don't care that much about performance, about efficiency. What we care about is having this data replicated for safety reasons so that everyone can access and see the same data, right? We still don't need to care too much about what that data is, right? So that's where Bitcoin or Ethereum are going to come into the picture. So for now, we just want to see what it is that is offered by the technology. And the main first thing that we have is everyone has the access to the same data. In practice, of course, not every node is going to really have everything on its own disk itself for capacity reasons, but it's important that the option is there for anyone. So data is stored in blocks. So you have these blocks that are linked together in a chain, and this is the storage that we're talking about. So at this point, you would usually hear people say that blockchain is like a distributed database, but that's not really true, because a database implies tables, it implies manipulating the data and things like that, which is really not the case here. You can just treat it as like a storage layer where you have these blocks that are of a fixed size, typically, not always, but typically, say 1 megabyte or whatever, and then you can store any data you want in these blocks. These blocks are then linked so that each subsequent block has some part of the information from the previous block. That's the linkage part, right? And then the difficult thing here becomes how to add things to the blockchain, right? So if we all have some sort of data written and every computer in the network has the same data written, anyone can check that the data is the same, that's fine. But if I want to add something to this data system, I propose something should be added. How is this going to be added to the blockchain is an important question. And the point where this question was answered was when Bitcoin really came about. The initial Bitcoin developer was Satoshi Nakamoto. It's just a pseudonym. It's someone hiding behind a name. We don't really know who that person is. But what he came up with is a consensus algorithm that helps solve this problem. There are many consensus algorithms used in different blockchains, but the essential thing that they do is they help us determine one node at random that's going to temporarily get the advantage of being the one adding data to the blockchain. So in a centralized system, typically what you would do is you would have data only in one place, and this centralized authority would control that data. They would be able to manipulate it, to add things, to change, and things like that, work perhaps behind their client's back. In a blockchain system, we want to eliminate that, and the consensus algorithm is the way to eliminate it. Now, consensus algorithms, they work in different ways, but usually it's some sort of staking mechanism, right? So any node can be one of the ones that are potentially going to be adding data to the blockchain, and they have to put some skin in the game. They have to give something up front to make the system know that they care about this. And then we're going to have a consensus algorithm that's randomly going to pick a node, and then this randomly picked node is going to be the one to create a new block. Now, the data that's contained in the new block is going to be just some proposed data that was proposed by anyone in the network, right? So that's enough of abstractions. We can go into a particular example. So Bitcoin is one application of this kind of system. And what Bitcoin did is they wanted to have transactions written in blocks. So we have declared that there's this numeric value that's Bitcoin. That's just the cryptocurrency Bitcoin that is stored on different accounts in the system. And these blocks are just going to have transfers between different accounts of this Bitcoin cryptocurrency. And then anyone can propose a new transaction. So they just publicly declare to everyone that they want to add some sort of a transaction where they send some amount of Bitcoin to someone else. And then everyone is aware that this transaction exists. we randomly pick a new node that's typically mining work, right? So we randomly pick a new node that's going to be adding the block to the blockchain, and then this mining node takes some transactions, adds it to the block, and declares to everyone that, okay, this is the new block. At the same time, everyone adds this new block to the chain. And once that is done, again, everyone has the same transaction history written down. We can use now this system, for example, to have like a complete financial system that is outside of any specific authority. It's typically called a trustless system because you don't need to trust a bank or a government or anyone else to maintain your data, right? So typically in a conventional financial system, a bank usually won't do this, but they have the opportunity or possibility, or if they are ordered by the government, they can deny you access to your funds. In a system like this, this is literally not possible because the blockchain is owned by everyone, right? So you can treat it as like a sort of communal ledger, a communal writing system, where none of the players in the game has control over the entire system. And this is very interesting and fun. And also, like, another important part of this is, while the system is completely transparent, it also helps the users maintain their anonymity if they wish it, right? So the transactions in the blockchain are going to have user addresses, but you personally don't have to be tied to that address anywhere specifically, right? So you know what's your address, and everyone else knows what's your address. To send transactions, you use a private key. So it's like a simple cryptographic mechanism used in Web 2 all over the place. So you have a private key that you use to send transactions, to sign them, and to make sure that no one can send transactions in your name. And this is where the crypto from cryptocurrency comes from, by the way. Yeah, that's basically how Bitcoin decided to use this infrastructure. While Bitcoin was doing this, there were many people thinking about ways to use this technology for something else. For example, writing down legal documents, writing down a company policy, things like that. Things that you would want to be owned by a group of people working together, but not by one specific person or one specific central authority. And this is where Vitalik Buterin came in. And this is where, for us developers, everything becomes much more interesting, which is the Ethereum blockchain. So Ethereum is just a different chain that's separate from Bitcoin, right? You have different nodes working together on the Ethereum blockchain. And what Vitalik suggested was to start writing code down in blocks. So this is where things become very, very exciting, because this opens up a whole new potential for different things that we can do. And this is where all the hype starts coming. So we can store code on the blockchain. We call this code smart contracts. You can see an example of a smart contract here. And we're going to go over this. This is like a very simple example of a smart contract being written badly. But we can use it as an example of, like, you can see how the code looks. If you've written any sort of object-oriented language, the syntax should be familiar to you. But let's just go over what Ethereum can do. What are all the differences from the previous blockchains? So we have these smart contracts. Deployment of smart contracts onto the blockchain is completely transparent. So as a developer, when I write a smart contract, I can put it up on the blockchain. It's going to get an address. And once it's ready, once it's prepared to be used by others, in subsequent blocks, they can invoke functions from this smart contract, right? So in the blockchain, we're going to know what are all the different smart contracts that exist. They're going to be completely transparent. And then whenever we use a smart contract, it's going to be publicly visible that we have done it, what was the outcome of that transaction, and so on. So you can think of it like open source, but on crack, right? It's a very powerful and open development platform where you can also think of it kind of like having a backend for your system that is owned by the community of your users, and the storage layer is also owned by the community of your users. So you develop some sort of software, and then you put this software out there into the world, and you don't get to execute it, right? When your users want to use your product, it is executed by everyone all at once, and everyone can see the outcome of that execution, and that's the end of it, right? yeah, so the user base sort of maintains and pays for the infrastructure. And the use cases for this are sort of difficult to find and weird. That's why blockchain hasn't really taken off, aside from decentralized finance, right? So where you've probably heard about blockchain so far is cryptocurrencies, crypto exchanges, NFTs, things like that, which are all applications of this system, right? All of these are actually written on the Ethereum blockchain, where if you want to have a token of your own, what you do is you write a smart contract like this that basically controls the flow of your token. You're just going to have lists and maps and data structures defined in here that say how much of your token is owned by anyone particular on the blockchain. And then you're going to have functions for adding tokens, for removing tokens, for selling them, transferring them, things like that. And when you start thinking about this in this kind of way, it's very natural to start rushing to develop new possible products on this platform as quickly as possible, because this is something that's completely outside of the norm, right? So your users can execute your code with complete certainty that what they are executing is what it is. They can see the code, they can see the execution, they can see the outcome, and they have zero need to trust you as a company that you have been acting fair, which like typically you will always be acting fair, of course. But just giving your users that sort of peace of mind that they don't need to trust you, that they don't need to worry about their data leaking or something like that, is a very big thing for many different companies, and especially in finance, this started happening a lot. So we can start going a bit into the nitty-gritty of the code, right? So here you have like attributes, right? It's just variables like in any other language, and you have functions. These functions are going to be called by users later on once your smart contract has been deployed. So here in this particular example, what we wanted to do is we have this password that's given to the contract in construction, right? So when you call the construction, that's the deployment. And as a deployer, I might be putting this contract out into the world. And as I'm doing it, I'm passing in a parameter, which is this password, and that is being stored in the memory of the blockchain. Now, one thing that's specific and a bit different about Ethereum development from conventional development is your variables are actually stored like on the disk. They're hard stored because transactions need to maintain their state, right, from transaction to transaction. So this is not just memory, it's stored literally on the disk. And every node has access to all of this data, right? The public and the private keyword here are used to denominate that other contracts can access this locked variable and cannot access the password variable. But all of this data has to be on each of the node because each of the node is going to want to execute this code, right? So each node will know the password and it's just going to be stored as a 32-byte variable here. So then, after deploying this contract, I might pose a challenge to someone to hack this contract by figuring out the password and calling the unlock function to find the password. And once that is done, it's going to set the locked variable to false. And so this is a simple example to show that blockchain development can look the same as conventional development, but have very different implications. As I mentioned a bit earlier, this password variable is going to be stored on each node. And any node operator, so anyone on the blockchain that is simply running an Ethereum node, can, if they want to access this password variable, it's just like a specific function that you call on the node and then you get the value. Also, since this contract has been deployed to the blockchain, the transaction where it has been deployed is also stored on the blockchain, along with the parameters that have been sent when you were doing the deployment. So I'm going to deploy this. I'm going to tell you at which address the contract is. And then to hack the contract, all you need to do is find this address right on the blockchain and just look up all transactions that happened connected to this address. And the first one, the oldest one, is going to be the one where the contract was deployed. You can just extract the parameter, see the password, and that's it. Right? So all data on blockchain is always transparent. If you want to do something like this, you would have to like encrypt data and then have it sit encrypted on the blockchain. But like typically you just don't do this, right? So the Applications for blockchain are typically of a nature where you want all the data to be transparent, right? You want everyone to see everything that's going on. So what could be some actual use cases here? So why is this interesting? Why is this fun? So the first really big thing that blew up with blockchain, with Ethereum application is decentralized finance, where you have, for example, decentralized markets, decentralized exchanges. You have systems for investing, for lending, for borrowing, things like that, that all work through smart contracts. So you can imagine an exchange that doesn't have some sort of central bank dictating how much is the value of exchange for some different monetary values. You just have math written down in a smart contract that anyone can look up. And then once the user has seen how the exchange is going to work, he can decide whether to use it or not. And then some amount of value, some different tokens or currency or things like that can be stored in the contract itself. So since the contract has its own address, it can store Ether, it can store tokens and things like that. So we can also use smart contracts to do arbitrage for us, or maybe to do some sort of smart transfer of currency or things like that. Another interesting application is for community projects, right? Where, for example, you might want to run some sort of charity project. And in this charity project, you don't want any one specific person to control all the charity funds, and you want anyone publicly to be able to join the charity. So what you do is you write a smart contract that's going to have rules written inside of the contract itself about voting for different things we might want to fund, about managing how we add funds to our charity, about managing like how to add new people to the charity and things like that. And then when we start using this system, once it's deployed to the blockchain, no one specific user can override the others, right? So we can just use the system like completely transparently among each other, and then have no one specific person control it. So in these sort of situations, the blockchain starts to become interesting. There is no really big use case for blockchain yet outside of decentralized finance, because this is where people started getting really excited about having new ways to do anything related to money, related to finance, right? Things like funding companies, right? Things like stock option management. They're all sort of in there, kind of, through different tokens and things like that. But that's where it basically stopped. This is also the point where a lot of hype started being generated around blockchain and money being invested without really the proper practices developing. So this is where we started getting an influx of a lot of investor money, influx of a lot of users getting hyped and believing in the blockchain very much, and then spending a lot of money inside the blockchain very much, without the system really being mature enough for that level of hype. So some typical issues that happen to developers is preconceptions. So we can use the example of the previous smart contract, but as a developer, you're going to have some ideas of how you do development work, and then sometimes these ideas are just going to not work on the blockchain simply because it's outside of your control, because it's used by everyone and not only by yourself. Lack of tools. So for example, it's very difficult to test or to stage code on the blockchain, right? So when you start working as a developer on the blockchain, you can do some sort of development on your own machine, but you really need the rest of the ecosystem. You need every smart contract that is deployed. You need the state of all of those smart contracts to be correct when you want to test. And to do that, you can go to production. That's one choice. Or two, you can just try imagining how things are going to work it out on paper and things like that. But as experienced developers, I'm sure you know that this approach is really not scalable at all. And then sooner or later, you're going to introduce some sort of mistake. And sort of excruciating factor here is that your code is always completely transparent to potential attackers as well. So everyone is going to know what your code looks like because everything is hyper open source. And then this means that your code, once you deploy it to the blockchain, really needs to be very, very good. If it isn't, someone is probably going to find some sort of issue with it, right? And then what the community really needs is tools for debugging, tools for seeing what might happen if I input this value, what might happen if I input that value, what would happen 1,000 blocks from now when my code starts working differently. Simply asking these different what-if questions is something that developers really, really need, and blockchain as an infrastructure doesn't offer it on its own, right? Lack of documentation is also another very big thing. The space is expanding very, very rapidly. And when the space is expanding very, very rapidly, what you do is you try to make things work, and you don't write down how they work. So when you want to use some sort of smart contract that offers you a service as a developer, it can be very tricky because you need to read the code as documentation, which can be very, very difficult. And then a week later, things are going to change, and then you're going to have to readapt and things like that. Lack of experience. So there are really no good safety practices established yet in the blockchain space. Some are being developed. People are working on this. But it's really a very, very new field. While there are design patterns that are being used, some developed completely new for the blockchain, we need a lot more of them, right? And you may be aware that currently we're in something that is called a crypto winter that started like maybe towards the end of 2021, where there have been enough different blockchain-related scandals that people started to lose hype enough that a lot of cryptocurrencies lost value. Right? So Bitcoin lost value a lot, Ethereum lost value, and then many other tokens also started losing value. And this has led to a sort of like downsizing of the blockchain. There are not so many new projects being developed right now. There are some people are working in the space, but only on new grassroots ideas. And the hype has died down a little bit. And this is actually kind of healthy for the system, even though like nobody in the space really likes it that happened. But it is in a sense sort of healthy because it leads to all of these things starting to be solved step by step, right? One by one, because things are slowing down, because we aren't rushing so much. During the huge hype around blockchain, which started at like 2015-16 and then lasted till about 2021. Everyone wanted to make the next big thing before the bubble bursts. And then this led to bad code being written, to working just inside your head and not using proper tools, not developing your own tools and things like that. And this meant that there was like a lot of work being done that's just not supported by proper practices. And then what happens is every week or every 2 weeks, there is a new sort of fiasco that you hear about on Twitter, some sort of crypto exchange being swindled or swindling its own customers or things like that. And then users start to lose confidence, right? Awkward terminology. So I didn't go too deep into that in the previous in the start of the talk, but there are many terms inside the blockchain space that sound the same as things you might have heard in different development areas, but are completely different. So, transactions are a great example. So you have transactions in financial systems as like sending money. You have transactions in database systems, which is just like changing the state of the database. And transactions on the blockchain are neither one of those. It's just a completely different thing, because a transaction on the Ethereum blockchain, it might send some Ether from one address to another, it might not. It might change the state of the data on the blockchain, it might not. It can be reverted. That is one thing that all the transactions do have in common, where a transaction on the Ethereum blockchain, it's going to start executing. If it runs into an error, it's going to roll completely back and then stop, and then it's not going to be executed at all. So in that sense, it is a transaction, but it implies a sort of meaning that can be completely misinterpreted just because you don't know enough about the system. And this is something that's like very inherent and prominent in the space, and something that really needs addressing. So, what is our approach to all of this? So now we can loop back to Tenderly. So as I mentioned in the start, what we do is we develop tools for blockchain developers. So basically, what we want to do, our mission is to professionalize the space as much as possible, right? And I'm not going to go on a whole charade about our product portfolio or things like that. What I want to talk is our approach to solving these issues, because what I'm hoping you can come away with, even if you're not in the blockchain space and you don't care about blockchain at all, which is completely fine, hopefully some of these can be useful lessons to you, either if your work is targeted at developers or if you are working in some sort of high-tech niche or things like that, because these are all very common and natural problems to have when a space is developed in the context that we explained earlier. So what we do is we focus on the tech as much as we can, right? So we look at what is possible fundamentally by blockchain and then differentiate it from what is not possible, right? So we need to have all of these things straight, because we need to know, right, there are all of these exciting new things that we can do, all of this hype, where we can do things that are completely new, that were not possible in Web 2. But we also need to accept that blockchain has its own limitations, right? There are issues that are simply not solvable on the blockchain, and then let's recognize what those are and just not to do things that are not supposed to happen on the blockchain, not to do them there. What we also try to do is we cut through the hype. So it's very important in this space to look at people that are really investing actual work, actual research, and doing things in a way that's productive and functional and addressed to the users, because a lot of those kinds of people exist in blockchain. It's very easy to think that blockchain is full of scam artists and people just talking about like the new investment, the new quick way to earn money and things like that. These things absolutely exist. But what's important is to cut through all of that and try and find who are the people and what are they working on that is like really, really insightful and new and exciting, because there are many, many projects such as those, and then connect with those people. Specifically at Tenderly, what we do is we try to go to as many Web3 conferences as we can all around the world. We talk to our customers all the time. We stay in touch with them over Slack, like literally directly. We have connected Slack channels talking to some of the biggest players in the Web3 space, because we can learn from them and they can learn from us. And this is very big and very useful. Lastly, I'd like to mention like acknowledging inherent weaknesses. This is like, I think, probably the most important part of our approach, because what we want to do is basically to accept that the technology isn't perfect, right? There is this term Web3 being floated around about blockchain, and while this term is in some sense true, that Web3 is fundamentally different from Web2, the implication that it's completely going to replace Web 2 is probably just like too optimistic, right? Because there are simply things that are better done centralized. And then let's do those things centralized and find where the decentralized stuff works and then use it there. So also on Tenderly, regarding my own personal part, what I do since I came from academia is I help all of our employees understand the merits and weaknesses of blockchain so that we can all be on the same page about what it is that we want to do. And I think that this is very, very important, and something that's very commonly lacking is to just have the main knowledge represented to everyone as clearly as possible. In our particular case, that's very difficult because blockchain isn't simple. Here we have like a full 40-minute charade about just introducing the basics. But it's like very important to have this not only for the developers but for everyone as well, and have that knowledge adapted to a level where everyone can understand it clearly enough to have a good idea of what it is and what it isn't. Okay, so to close up, there is this very cool and nice thing about Web3, about blockchain in general, where it is really, really very, very open. So it's very democratic, it's very open source centric, it's very collaborative. People are always eager to hear your next idea and then help you working on it or share their ideas with you and things like that. So even if you aren't in the blockchain space, what I would like to do is just embrace that spirit, because in my opinion, that's the most positive thing that you can find in this space. And then just try to work as openly as we can, share knowledge at conferences like this one, at just public gatherings, anywhere where you can find new developers, new people investing, things like that. So we can all basically empower each other and help do as best work as we can. Thank you. So, any questions?
Hello, I gotta say, very nice presentation, but one of the things that's been bothering me, people say all the time that, for example, Ethereum and Bitcoin are truly anonymous, but do you think that's really the case? And what do you think about, let's say, Monero in comparison?
Sorry, can you repeat the second question?
So how would you compare, let's say, Bitcoin and Ethereum in comparison to Monero when it comes to anonymity?
I see. So the question of anonymity is an interesting one. It's like, let me just think about how to frame it. The thing is, nobody needs to know who you are on the blockchain if you don't want that to happen. That is perfectly true. However, your interactions on the blockchain are going to start generating some sort of identity for you that people can try and sort of like tie to like a sort of behavior pattern or things like that, right? Because everything that you do will be transparent and you will always be behind a single address. Or if you're not behind a single address, it will be probably very easy to track down what are your different addresses on the blockchain because they're going to interact with each other, right? And then there might be some sort of behavior pattern here happening where people can find out, right, something about you, if not necessarily your identity. It is definitely very, very true that if you want to just work on the blockchain and you care about your anonymity, it is most definitely possible for you to not leave a trace linking you back to your actual person, right? That's definitely true. And then as for the different networks, right? So it's really important to look into each specific network before you start using it. That's very important. And one of the downsides, I think, of this technology is you need to really be aware of what it does and how it works before you start using it. So Bitcoin and Ethereum specifically, they are very pro-anonymous. I think like it's very easy to hide your identity on these systems if you want to. But there are different networks that simply don't prioritize it. And then it's going to be more difficult there. So it's really important to figure out what is and what isn't possible on the specific technology before you start using it, or at least consult with someone who you can trust, who you think is capable enough to do that for you. Yeah. Okay. Any more questions?
Yeah, it's working.
Yeah.
Hey, Mane, thank you so much for this one. Two parts to the question. So if we step a step away from the banking, right, just for a minute, because it's really choking blockchain.
Sure.
What would be the next big thing that could catapult it, right, to become the global standard? And with all the things happening, how do you envision the tools, the AI, implementing and working with it, not against it?
Yeah. So both of those are very exciting questions, right? For the first one, like if I knew I would be doing it, right, and would probably be a millionaire by now. So finding the real application that's going to catapult blockchain again into the public eye and be the real next big thing aside from DeFi. I mean, I'm sure that it's going to happen sometime soon. It definitely exists. But finding it is going to be difficult because adoption is a very big problem here. So basically all of the big ideas that people had so far have this problem of needing to integrate with like existing social structures or things like that, which always have this stopping and slowing down motion. So we need to find something that's important enough to people, such as banking and finance, but free enough that it's not like already ingrained into how we do things. So I'm honestly not sure. So probably it would be some sort of like either community-driven efforts or things like that. So perhaps organizing events such as this one, or working on globalizing some sort of product or things like that. These are directions that people are working on that seem promising, seem interesting, but really haven't blown up yet. partly because people have lost a lot of confidence in blockchain recently. So now it's probably going to slow down. But I think it's definitely worth thinking about and trying things in this space because something is going to blow up soon, for sure. And then regarding AI, so AI is probably going to get involved in most everything that we do. This is not strange to say right now. It's becoming very, very obvious. I'm sure that AI will find its use inside blockchain as well, either through tools such as the ones I mentioned, definitely there. So analyzing smart contracts, for example, is something that people already do with AI, and getting improvements on that front is going to be huge. So finding potential exploit, finding different things that where you can interact between different contracts and then have them do something good or bad or things like that. These can be very, very complex because there are many smart contracts that interact in complicated ways. And then finding that by hand is very, very difficult, but an AI might be able to do that. There are also other applications for AI simply in DeFi, if we take DeFi as an example of a blockchain application, but then this could be used for different blockchain applications as well. These systems are also very, very complex because you have a lot of very small elements interacting with each other. These can be end users, but they can also be like smart contracts, they can be Web2 scripts, things like that. And then figuring out ways to leverage those could be a very interesting task for an AI, right? So these are just some of the top of my head that come to mind, but like I'm sure that there are going to be many, many others, because not only in the blockchain space, but in many, many different areas of IT, AI is going to start becoming very, very prominent very quickly. Yeah. Okay.
Okay. Test. Okay, so I have another question going back to smart contracts. So I wanted to ask, what are other things that you can do with them when it comes to trying to exploit it? Is there any way that you can maybe crash the whole cryptocurrency? I don't know, maybe I'm just talking out, just making some stupid questions, but yeah. I wanted to ask, is it any way exploitable to extent where you can literally destroy the currency itself?
Yeah, so that's a very good question. So this is something that's been asked by Vitalik when he was designing Ethereum specifically. So a very obvious attack that someone might try to do is to just write a smart contract where there is some sort of function with a loop that's very, very long, and then just deploy that to the blockchain, and then in the next block just execute that function. The attacker is going to hope that every node in the system is going to try to do it, because every node needs to get a consensus about what's the outcome of the transaction, and that's just going to crash the entire system. To circumvent this problem, Vitalik introduced something that's called gas into the system. So this is also a term that you might have heard connected to blockchain. So gas is just a way to tamper execution, basically. What you do is whenever you want to do a transaction on a blockchain, you need to pay upfront. So as a user, just doing a transaction, you need to pay upfront in Ether, which is like the local currency of the Ethereum blockchain. And then this Ether that you paid is used as gas in execution of the function. And then basically what the system does is, for each instruction, there is a predetermined cost in gas for executing that instruction. And then when your function starts running, there is a counter that goes up, up, up for each transaction that you are doing. And then if at any point the gas that's being used by the function becomes more than what you paid upfront with Ether, the transaction is reverted, it's canceled. We write down in the block that you tried to do the transaction, that it failed, and you lose the gas that you paid upfront. So this seems very inconvenient for the user, but it's the price to pay for having distributed and publicly owned infrastructure, right? Someone needs to maintain it, and it's the user maintaining it, so gas is a part of that. And so, for example, you can also use gas to change how much the system throughput is allowed, right? Because if gas cost is low, then people can add many, many transactions to the queue. But then if there are many, many transactions that need to be done and we want the system to slow down, what we can do is we can raise the price of gas, and then a lot of those transactions are going to fail, and also new transactions are going to come in slower. So this is a way to basically make sure that the system can do all the transactions that it needs to do. It's getting, the queue is not becoming too long for potential transactions. And what this means is that at some point you might want to do like an exchange, just buy one token for another, and you need to pay $5 US in gas money, and then 7 hours later you try to do the same transaction, and now you need to pay $50. So this is something that very naturally happens on the blockchain, and obviously it's a big turnoff for a lot of people wanting to use the system, where before you even interact with anything you need to pay up front, and then maybe even the money that you paid up front is going to just vanish because the system was too overloaded, right? But it's something that we have to do to defend from an attack which you mentioned might be possible, right? Other than that, just through smart contracts having exploits that can like crash the entire system, that's not really possible, because each node can, if they want, just reject a transaction, and there are safeguards in place to make sure that if something like that starts to happen, the node is just going to drop execution and continue on with its own life. So nothing smart contract-wise can harm the infrastructure itself. This would be the only possible way, right? But the gas serves to solve that problem, so that's it. Yeah.
Thank you. Now we can talk about security for another hour,
exactly.
but we have to wrap it up as we are trying to stick to the schedule. Thank you very much. Can we have a big round of applause?